Hey guys, welcome back to my YouTube channel. Do subscribe to our channel, and today we'll see about thermal conduction of heat.
Guys,
So
now
without
we see about thermal conduction of heat. You can see the picture here. A candle is lit and a person is holding one iron rod. He is keeping it near the candle. So the flame is the flame's heat is getting transferred to the iron rod, and you can see clearly in the picture. So we'll see more about this. Now, what are the contents in this presentation? First is introduction, then what is conduction, then what is the principle of conduction, conduction in solids, and some of the examples of conduction, and finally conclusion. Introduction. Heat transfer is a science that studies the energy transfer between two bodies due to temperature difference. There are usually three modes of heat transfer. First is conduction, then convection, and last radiation. Here you can see the picture which depicts the conduction, convection, and radiation. What is conduction? Conduction is a mode of heat transfer that occurs when there is a temperature gradient across a body. Here you can see the picture where it is a conduction as demonstrated by heating a metal rod with a flame. So the person is holding a metal rod, which is at room temperature. When it is kept near the flame, the heat is getting transferred from the flame to the metal rod through physical contact. Okay, what is the principle of conduction? When hot body is kept in contact with cold body or an object, then the quantity of heat lost by hot body is equal to the quantity of heat gained by the cold body, which is called as the principle of heat exchange. Conduction occurs when heat is transferred via atoms. So here is one example of heat conduction you can see there. Conduction in solids. Conduction occurs more readily in solids and liquids where the particles are very close to each other than in gases where particles are further apart. The rate of energy transfer by conduction is higher when there is a large temperature difference between the substances that are in contact. Here you can see the tabular column. I have listed below some of the thermal conductivities of some materials at room temperature. Diamond is having the higher thermal conductivities compared to other elements, and one of the gas elements, which is air, which is having the lowest thermal conductivity. Thus, it is efficient in solids than in liquids or gases. Okay, these are the few examples I have listed here. So you can see the images. First is the hot coffee, where the heat from the hot coffee makes the cup itself hot. So heat is getting transferred through physical contact. Then ironing. So the material which is having the heat source, when it is kept near the contact of the material, so heat is getting transferred to that material. Then ice cube on our hand, so it starts melting. So it is because of the heat from our hand, which is transferred to the ice cube, which becomes melting. Then you can see one cup of coffee or a cocoa where I have kept one spoon. So that cold spoon is becoming hot because of the hot cocoa. Heat conduction is essentially the transmission of energy by molecular motion or atomic motion. Thermal conduction in solids is due to two effects, mainly the transport by free electrons and lattice vibrations. As I said earlier, it is because of the collision between the atoms or molecules. Conduction is greater in solids because the network of relatively close fixed spatial relationships between atoms helps to transfer energy between them by vibration. As I said earlier, it is because of the lattice vibration and that is collision between the atoms, which is making the conduction is efficient in solids than in fluids and gases. So thus, fluids and gases are less conductive than solid. Thank you guys for watching this video. Actually, I am just a student, so if you see any corrections to be made or any suggestion, you can comment below in the comment section. So please let me know. Thank you.